At this time, we are going through the details related to writing basic SQL queries based on the requirement. The problem statement in requirement say compute daily product revenue considering only complete or closed orders. To come up with a query to get daily product revenue, we need to make sure orders and order items are joined. As part of this lecture, let's go to the details about joining orders and order items, then we'll take it further. When it comes to joins in Postgres or any standard RDBMS, we'll be able to perform inner join, outer join. Again, as part of outer join, we have left outer join, right outer join, as well as full outer join. Also, we have concept called as Cartesian product or cross join. These are the typical types of joins which we can use in any standard database. For our problem statement, we need to come up with a query using inner join, but in many cases, we might have to use outer joins as well. First, let's go to the details about coming up with a query using inner join, then we'll take it further. As I have mentioned to you earlier, when it comes to writing the query, it has to start with select. Let me just say star here. In this case, we wanted to project all the fields from both the tables that will be part of join. Then we need to specify from clause. As part of from clause, we should be able to use join. To use join, we need to have two tables. The first one is nothing but orders. The second one is nothing but order underscore items. However, between the two tables, we need to use a keyword called as join. So in this case, we can say join. Then we can specify the other table, which is nothing but order underscore items. After connecting these two tables using join, we also need to specify the join condition. Typically, the join condition will be based on the primary key and foreign key fields. When it comes to orders, the primary key is nothing but order underscore ID. When it comes to order underscore items, the foreign key is nothing but order item order ID to orders order ID. We need to make sure we understand the relationship between the tables, and then we have to identify appropriate field based on which data is supposed to be joined. In this case, it is nothing but order ID. In orders, order ID is represented as order underscore ID. In order underscore items, order ID is represented as order underscore item underscore order underscore ID. You can review the data model diagram here. You can see that orders and order items are related. Between orders order ID and order items order item order ID, we have one-to-many relationship. Hence, we should be able to perform join using these two fields when we want to join these two tables. Now here we have to specify the join condition. The way you can specify join condition is like this. You have to use on clause. As part of on clause, we should be able to specify the condition. Typically, when it comes to joins, use aliases for the tables. Hence, let me say O as alias for orders and OI for order items. When it comes to aliases, the best practice is it has to be short and concise. However, it should make some sense when we look at them. We should not be using A and B. A and B doesn't make any sense. If we say O and OI, we can relate them to orders and order underscore items easily. Just need to think from those lines and then specify the aliases. Now, as part of on clause, we can say O dot order underscore ID because orders have order ID. When it comes to order items, we have to specify order underscore item underscore order underscore ID. This is the field which actually mean order ID in order items. This is how you should be able to join two tables. Now, if you run this query, you will see all the records which satisfy the join condition. We have total 172,198 of them. As we have specified star, it is projecting all the fields from orders as well as order underscore items. Now, in case if you wanted to project only the fields from orders, then we can actually say O dot star. It will only project the fields from orders. You can also use the full table name rather than alias, but using alias is good practice. Typically, we'll get all the fields from one table. From the other table, we might want to get only one or two fields. Also, there could be scenarios that we get only one or two fields from one table and then one or two fields from other table. Let's say we wanted to get order date from orders and then order item product ID as well as order item subtotal from order items, because when it comes to daily product revenue, these three are the important fields. We should be able to specify order date from orders like this. Then we should be able to specify order item product ID from order items like this. Then we can actually specify order item subtotal from order items like this. Now using this query, we should be able to get only those fields which we are interested in. Let me run this. You can see the output as per the expectations. This is how we will be able to join two tables. However, in case if you want to perform join between three tables, you have to add one more join. You have to specify the table name and then you have to specify additional condition using on within that join. You can join as many tables as you want as part of the queries. So far we have covered only inner join. Now let us talk about outer joins.